So the first thing that I want to go over is something that's on my wall. And so you guys don't have this, but it's hanging on my wall. It might be hard to see because the low lights kind of put a glare on it because it's laminated. So I just have the exact same thing up here. And that way it's in the video as well. We have 4 different vocabulary words, and we need to make sure we're using these words appropriately. Or if the directions have these words, you need to know how to write your answer. So the first, there's 4 posters, 4 words. The first one would be that graphs have x-intercepts. If you're asked to find an x-intercept, you would find 2 ordered pairs, or however many there are, but like in this case, we would look at this graph and say, okay, at 2, 0, there's an x-intercept, and at -1, 0, there's an x-intercept. Okay, so if you're asked to find x-intercepts, our answers are in ordered pairs. But here's a word that a lot of people mess up a lot. Solution or solve. You guys don't always use that in the proper context. So when we have an equation, we can find solutions. Now, you will notice in this equation, first of all, there's an equal sign. So you can't find a solution if there's no equal sign. You cannot solve it if there's no equal sign. So to find a solution, there has to be an equal sign. Also, this equation does not have a y in it or an f of x. You see, this equation only has one variable. So if I'm asked to solve, I'm going to solve for x because that's the only variable there. So when we're asked to find solutions, there's only one variable. All right? And then look how I wrote the solutions. X equals 2, x equals -1. And you'll see I will actually not write it twice because I don't want to. I'll write it x, and then I'll have the fancy bracket, and then I'll have a list of all my x's. That's another way of writing them rather than having x equals this and x equals that. You can just make a list of all your x's. So you'll see me write it that way as well. The next is an expression. Expressions do not have equal signs. They don't have equal signs. Do you see? No equal sign. But expressions have something called roots. And a root is a number that if I plugged it in for x, it would make the value equal 0. The root would make the value equal 0. Okay, so if you're asked to find roots, that would be for an expression. Do you see these equations? I don't know if you noticed, are the exact same equation. Oh, and it just broke my own rule. One of them is an equation and one of them is an expression. Do you see the expression part of both of these is exactly the same? They're both x minus 2, x plus 1. Do you see both of our answers are -1 and +2? So we must be finding these answers the same way. They're just different vocabulary for the answers. In fact, look at the first one. +2, -1, same answers. We're going to be finding all these basically the same way. And then the last one is functions have zeros. So you see this one is a function. It has f of x in it. It could be y equals. But in this function, the values that I would plug in that would make the function equal to 0 would be 2 and -1. Those are the zeros. You see that's the same answer as the ones above it, and the ones above it, and the one above it. It's just we're answering different questions because their original is starting just slightly different. So we need to know what to do if we're finding zeros, or we need to understand what to do if we're solving, which it might actually be the same work, but you're writing your answers possibly different. Or if I say, find me x-intercepts, those are the only ones you're writing as ordered pairs. Okay? So today, we're going to be doing about half of that. I want to show you, I'm just going to use this empty area right here, and I'm going to write on it, it was x, oh no, what was it? -2 and x plus 1. One of them had f of x equals. One of them had that equals 0, and one of them didn't even have an equal sign at all. But all of them had the answer of a positive 2 and a negative 1. All of them had those answers. So now these are two separate answers. We would plug those in, not at the same time. You'd plug only in the number 2 or start over, only plug in the negative 1. So what I'm going to do is I'm going to plug those in. And we're going to figure out something very important for us to know for this course. If I plug in 2 for both x's, so I'm basically checking what they said were the zeros or the roots or the x-intercepts or the solutions. If I plug that in, I get for my first parenthesis 0 and my second parenthesis 3. And what's 0 times 3? Now, if I plug in the other number, this time I get negative 3 and I get 0. And what's negative 3 times 0? So both of them came up with 0, but I only plugged in one of those answers at a time. This is an important concept that is going to be very helpful for us in this chapter and the next chapter and the next chapter, and I could keep going. Okay, it's going to be very important to us. If it is in factored form, like this is factored form here, if it's in factored form, as long as one of the factors equals 0, doesn't even matter what the other one equals, because what am I doing to the two factors? Multiplying them together. If we multiply by 0, we always get 0. So, and you'll see that on this one as well. If one of them is 0, the whole thing is 0. And that's important for us to know because it's going to help us solve equations faster, or find zeros, or find roots, or find x-intercepts. Okay? So that's coming up. We're going to do this stuff in 2 days. Oh no, look, Harry Potter scar. We're going to do this in 2 days. Today, we're going to start with solving quadratic equations by graphing. So we did an entire chapter on graphing these. It's time to review graphing, okay? Because it does not go away. I'm just going to kind of skim through this. First of all, the standard form is ax squared plus bx plus c equals 0. That would be an equation. That would not be a function. Does anybody know why this is an equation and not a function? Jacob? Nope. A function has an equal sign as well. So that's not the part that makes it not a function. Jack?
A function usually has like g of x or y, and this one has 0.
Right. This one only has one variable. So when we have functions, we have an input and we have an output. This one does not have an output. You just like only has the input, only has x. Okay, or our only output is 0, so it's not a function, just an equation. Talks about a root, which we went over. That would just be an expression, not an equation. Something that we talked about when we talked about x-intercepts, but it also applies to all of these with quadratics. So we're going to apply it to quadratic equations. They can have none, 1, or 2 real solutions. Same thing with x-intercepts. We could have no x-intercepts. We could have 1 x-intercept. We could have 2 x-intercepts because all of this stuff is related. We're just calling it different things. You can find these solutions by graphing. That's what we're doing today. By using square roots. We've actually learned this, but reviewing it today. And then tomorrow we'll do it by factoring. We just don't have time to do it all in one day. Then if these methods don't work, we will go on and learn 2 other methods, but those are different sections in chapter 3, so we're not ready for those yet. So we're going to have 5 different methods of how to solve quadratic equations in chapter 3. 5 different methods. The first 2.5 we've already learned. So let's start by graphing. So we're going to solve this equation by graphing. Right now it is not a function. It is not a y equals. So I'm going to manipulate this so that we have a y equals. I'm going to manipulate it. I'm going to say that this part right here is going to be y1 x squared minus x minus 6. And then the other side of the equation is going to be a second y, y2 equals 0. So what I've done is I've put together something called a system of equations. Don't know how much you did with it in Algebra 1. We have a review of that coming up someday in this class. But here, this is a good time to start reviewing. When we have 2 equations, we can graph both of them. And then we're going to look to where they intersect. And that's going to be the solution. So what we're doing is we're taking an equation that has no y values in it. And we're saying, well, if y equals the left side and y equals the right side, by the transitive property, they have to equal each other. Did that sound familiar at all? A couple of you remember geometry. Have you done transitive property yet?
No.
You haven't? Okay. Really? Not yet? Okay. I don't know when you do it. Anyway, so if y1 equals, if y equals the x squared minus x minus 6 and y equals 0, where those two are equal would be where the two overlap. So first, y2 equals 0. The y1 or y2 is just telling me they're different graphs. The 2 and the 1 don't matter, other than here's one, here's the other. So just y equals 0, if I were going to graph that one, what kind of line is y equals? A number. That was chapter 1 for us. That's one reason why we spent time in it. What? Oh, horizontal is correct. Horizontal, yeah. So where would the y-intercept be? It is horizontal. There's a y in it. Where would the y-intercept be? At 0. So we'll have a horizontal line where it crosses the y at 0. Now, the second one is a parabola. We do need to know how to graph those, as we just took a test over it recently. So this is in standard form. I'm going to go through how we do it in standard form. The first thing that we do is we find the axis of symmetry. So it's like I'm reteaching the same thing we've already learned. So this should be good for you guys. You should know this stuff. Axis of symmetry, we have a formula. X equals, anybody remember? Negative b over 2a. We need to know that. That's coming back. So x equals negative, and then b is negative 1 over 2 times 1. So I get a half. X equals a half is my axis of symmetry. So I'm going to go over my graph, and at 1/2, there's my axis of symmetry. What do we find after the axis of symmetry? The vertex. To find the vertex, we plug in axis of symmetry. So we get 1/2 squared minus 1/2 minus 6. It's going to give me 1/4 minus 1/2, which is 2/4. Sorry, I'm skipping steps and going straight to finding common denominators. Minus 6, which is 24/4. So I get negative 25/4. Negative 25/4 is 6 1/4, negative 6 1/4. So there's our vertex. It's a little bit big. Make it a little bit closer to the 1/4. There we go. What else could we find? We need 5 points. I got 1. What else could we find? Nathan, are you talking?
Yeah, x-intercept.
Not ready for that yet. What other intercept? The y-intercept. Yeah, let's find the y-intercept. So that means we're going to make x 0. So we'll have 0 squared minus 0 minus 6, negative 6. 0, negative 6. So I go find 0, negative 6, and it has a mirror point. Now, if you did your assignment, which I know how many people have turned it in, if you did your assignment, you should be able to tell me how to find the x-intercepts. If you did not do your assignment, I'm going to pretend that nobody did it and we don't know how to do it yet. That's what the assignment's supposed to teach you. We're not going to find the x-intercepts. We just need to find how many more points? 2. So if I find 1, I'll get a mirror. Okay? So what can I plug in? 2. Okay, let's plug in 2. So I'll do one. Get my stylus to work again, maybe. Y equals, I'm going to do 2 squared minus 2 minus 6. So 4 minus 2 minus 6. Is that negative 4? Yeah. So we've got 2 negative 4. Okay. That does not, I mean, it helps me. But it doesn't help me get an exact answer where these two graphs intersect. Because I am not that great at drawing parabolas yet, because I just started it like a month ago, right? Speaking for you guys, yeah. So maybe let's find, it didn't take much effort to plug that in. Let's find another point, just for fun. Let's find another point. See if we can have more points to make it more accurate. What do you want to plug in? We just plugged in 2. What do you want to plug in now?
4.
That'll be 16 minus 10, so 6. So 4, 6. I didn't write the first point. 2, 4. 4, 6. Those are way far apart. I am going to possibly get where they cross, but somebody else said try 3. What, huh? I mean, it didn't take that much effort to plug in this number, so 9 minus 9 is 0. So we got 3, 0. Oh, and then I have I forgot, I can mirror them also. I just wasn't thinking there. Can mirror these. Oh, I didn't mirror that one right. Okay, I went above and beyond and gave way too many points, but my goal is to find where they cross. And the fact that I plugged in a number and got right on the red line, that makes me feel more confident that I have the right answers. So where do they cross?
0, 3, 0, -2.
I think you have your order pairs backwards. -2, 0, and 3, 0. Okay, so those are the order pairs of which they cross. My question is saying solve. But what's solve mean? Does solve mean write x-intercepts? I have it up in front. Does solve mean write x-intercepts? No, solve means solve for x. Remember, originally there wasn't a y in the question at all. I manipulated the question and put the y in so I could solve it a way that I was teaching you. But that's not really the question. The question is, what's x equal? So you look at these ordered pairs, what's x equal? 3 and -2. I'm going to write it in the other order. I'm going to say, well, x equals -2 and x equals 3. So we are reviewing graphing, because if you don't use it, you lose it. And we're finding where the two intersect. Okay? So let's just do 2 more practices of those. We're going to do number 2 next. on the next page. We're going to solve by graphing. So what should we do first? Haven't heard it yet. The AOS, thanks. So we're going to do x equals negative b over 2a. Notice how I'm still writing that formula every time. So you should be doing the same. So you know what it is. So we're going to do negative 12 over 2 times 8, or 2 times 4. Sorry, I was thinking ahead. Which 12 over 8, which is 3 over 2. X equals 3 over 2 is our GCF. Oh my gosh, I forgot to like separate these. So we'll do y1 and y2. We'll have y1 is the left side, y2 is the right side. I forgot to separate those. Okay, and then vertex, we'll plug that in. So we're going to do 4 times 3 over 2 squared minus 12 times 3 over 2 plus 9 equals 0. So we've got 4 times 9 fourths. And then I multiply this, that's 6, that's 18, minus 18 plus 9. And I get 9 minus 18 plus 9. Which equals 0. So our vertex is 3/2, comma 0. On my graph, I've got 1.5. My vertex is at 3/2, comma 0. And I forgot my other graph is at 0. What also can we find for this graph? I only have 1 point. Y-intercept. So plug in 0, y-intercept. I'm going to get 0 minus 0 plus 9. So I get 9, 0, 9. I think I got to count by 2s to fit it. And that gives me 2 points. What could I plug in? What can I plug in? I can plug in 1, sure. So let's plug in 1. I'm just going to zoom in above it. I'm running out of space. I didn't zoom in enough right at the beginning. So I'm going to plug in 1. I get 1. Is that correct? Is 1, 1 correct? Did I do my math wrong? 1, 1. Does it look right? Oh, yeah. It's just I'm counting by, here's 1, and 1 would be here. There we go. Okay, but then remember my goal. I mean, reviewing graphing is part of the goal, but remember my goal is to find where the 2 overlap, where the 2 intersect, which we actually did with our first point. The vertex is that spot at which the 2 graph. So what is the answer to this question? Corey, do you know what the answer to this question is?
Like, to the answer to the everything?
Yeah, the final answer to this question.
No.
Okay, you said something else. Were you saying what the directions were?
Oh, no.
What'd you say before?
Oh, I was asking you, like, the answer to everything, like, not just a little part of the equation.
It might be the answer to everything that you said. What are we trying to find here? What are we trying to find? Like, if I didn't do all this work and you just saw this original question, what are we trying to do? No, we're not trying to factor. Solve, which means find what x equals. That's what we're trying to find. Trying to find what x equals. So what does x equal? Right here. What does x equal? X does not equal 0 if anybody said 0. X equals 3/2. Y equals 0. There's no y in the equation. That's a y that I put in there. Okay? This last one that we're going to do, you're not actually going to graph it. I'm going to talk about 2 different ways that you could do this last question, and then I'm going to have it graphed on Desmos for you so you can just see it. Okay? This last question has 1 minus 2x squared equals 6x minus 20. So one way that you could do that would be y1 is 1 minus 2x squared, and then y2 is 6x minus 20. So this is a line. We have a y-intercept. We have a slope of up 6 over 1. You could graph that. And then this one here is a parabola. If I reorder it and I write negative 2x squared plus 1, this is vertex form with a vertex at 0, 0. It's got up 1. It's got a reflection. It's got a stretch of 2. So you could graph that too. So then you would find where they intersect. That's one option. And then another option would be to take the original question and move everything to one side. So I would take away 1, I would add 2x squared, and I would get 0 equals 2x squared plus 6x minus 21. And for that one, my y1 would be 0, and my y2 would be 2x squared plus 6x minus 21. Both of these should give you the exact same answer. They're just going to look different on the graph. So I'm going to show you the graphs, but you could do it either way, whatever you chose. You ready to look at it on the graphs? Okay. So here's the first way where I had the 2 separate sides. I didn't do anything, just made the sides separate. And I have to zoom out. But where they intersect would be at the 2 ordered pairs that I just clicked on. And again, we're finding the solution for x. So you would only write negative 5.071 and 2.071. Those would be your answers. So you remember those numbers, negative 5.071 and 2.071? So I'm going to turn those off. If I did it the other way, if I graphed 0 and I graphed 2x squared plus 6x plus or minus 21, and I'm finding the 2 places where they intersect, same answers, negative 5.071 and 2.071. So the exact same answers. So if you want to move stuff around before you find your 2 graphs to find where they intersect, that's fine as well. Questions? So we need to be able to graph. We need to be able to find where 2 graphs intersect. So that's the first method of solving quadratic equations. I'm going to be honest with you, not my favorite method. Seems like a lot of work. Okay, unless I'm using Desmos, it'd be like awesome. Graph, graph, touch, touch, done, right? Okay, so not really my favorite by hand method. You will practice 4 of them in your homework, but that's it. We're not going to do a ton of it. We will, however, do a ton of the rest of the methods. So our next method that we're going to learn is like our only other method we're going to learn today is using square roots. So this is going to look like an equation, like look at B. It looks a lot like what we were just solving. There's one side, it says equals 0. Okay, it's an x squared. We're going to solve this. We're going to do a different method using square roots. By the way, I taught this to you already. I just never called it using square roots to solve. When we had vertex form that looked kind of like question C, when we had vertex form and you had to put 0 in for x, no, for y, and find the x-intercepts, I taught you solving with square roots already. None of you knew how to do it because I asked you all. Nobody knew how to do it. So we learned this already. So this is going to be a quick reminder. Let's start with C because that one looks a lot like the ones we were doing before. So solving by square roots, you see there's no y in it at all. I just have to get x by itself. So we're going to work our way to get all those pieces away from x. What do I need to get rid of first? Ryan. What's the outermost thing that is on the x side that I need to get rid of first. How do we undo multiplication of 2/5? Corey? Division of 2/5. I'm not going to divide a fraction, Corey. I'm not going to do it. Can't make me. What could I do instead? Multiply by its reciprocal. That's what we're going to do first. We're going to multiply by 5/2. Both sides. So on the left side, I get x plus 3 squared. On the right side, I get 25/2. What is the next thing that we do? We're going to square root. Now, when I do that square root step, there's something else. Plus, minus. Very good, very good. So we'll get x plus 3 equals plus minus square root 25/2. By the way, the square root of 25/2 is the same thing as the square root of 25 over the square root of 2. Why would I separate those that way? Because what's the square root of 25? 5. Okay. So this is actually like plus minus 5 over square root of 2. Now, I need to talk about something that my other class confirmed that they didn't really remember it, but they remembered it. Like, it has been taught to you. We're not going to do a ton of it right now because we have a whole chapter where we'll do this. But there's a rule in math where you can't leave a square root in the denominator. So what you have to do in this case, and I got rid of the one that's like this in homework, so you don't actually have to do it in homework, but just a reminder, we would multiply the top and bottom by square root 2. If you don't remember that at all, we will review it later. Not later today, but later. And we would get 5 square root 2/2. So now I have x plus 3 equals 5 square root 2 plus minus 5 square root of 2/2. And then my last step, I'd have to take away 3. And we would have that x equals -3 plus or minus 5 square root 2/2. Now I put those in fancy brackets because there's 2 answers there. And they're not ordered pairs. They're just x equals. So now, you being able to solve it, I don't think I gave you any that come out that bad. I tried to not. How about number A? Letter A, I mean. This one, we've got 4x squared minus 31. You just start with adding 31. Get 4x squared equals 80. Thanks. I had stopped for a second. Then I get x squared equals 20. Then we do our square root step with the plus minus, and we get x equals plus minus square root 20. This is not the very final answer, because you can factor square root 20 to be the square root of 4 and the square root of 5. I purposely picked 4 and 5 and not 2 and 10. I purposely picked 4 because what's the square root of 4? And then the square root of 5 we can't find, so we just multiply it back in there. So you might have to simplify a radical. That would be a good question for you to ask me if you get stuck on that part. Because, again, we haven't reviewed that in here. It's something from Algebra 1, but we haven't reviewed it. We haven't spent time on it. And then the third one, I got to get through this third one. I would subtract 9. Then I would divide by 3. And I would get x squared equals -3. And then you guys are going to say square root. And I'm going to say yes, and plus minus. So I have x equals plus minus square root -3. Then you guys are going to say something to me. What is it? Oh, no. No brackets. You can't do a square root of a negative. Here I'm asked to do a square root of a negative, and I say, I don't know how to do that yet. Yes, yet. So for now, since I don't know how to do it, I'm just going to say that's not a real answer. There's no real answer that gives me that. So that's what we're going to say. Non-real answer. That's what we'll say for now. Until we learn how to do it. Like next week. Okay, that's all we're doing for today. I mean, there's some student practice, but we did 3 of them together. Your assignment on the module, which is not in front of me, so I can't show you, on the module is 4 graphs and then some, I'm just trying to go to it really fast. 4 graphs and then some of the square root kind. And then we will finish these notes and you'll have more for the assignment on the second part. So really it's the same assignment 2 days in a row, but I broke it up into 2 pieces. Okay. So you'll submit the first one and then we'll just basically have a new assignment tomorrow, same section. We just didn't finish our notes today.